Good morning to all.
Good morning, sir.
Good morning, good morning.
Good morning, sir. Sir, you asked me to remind you that we need to have a doubt lecture for electrostatics this week.
Yes. When is our next lecture?
The day after.
Day after's lecture will be exclusively doubt lecture because Sunday you have got a topic-wise test, right?
Yes, sir.
So day after's lecture will be converting it to a doubt lecture completely because evening this week is not possible anymore. Actually, I thought I'll take an extra lecture in the evening and finish it off. But कहीं पर set नहीं हो रहा है. So day after tomorrow's lecture will be exclusive doubt lecture.
Yes, sir.
What was the last thing we covered in capacitors?
So we were doing some questions, and the last question was that heat question, where heat is 0. We double the distance between the capacitors.
Sir, force between two.
Okay. Okay. So very technically, we should start with circuital analysis from here.
So we can continue in the same book.
Yeah.
Also, I did had a doubt from last class. Also, towards the end, the question that you had given, edge came out to be 0. Was it because of the way the numbers were designed, or in any case, it will always be 0, the heat loss?
No, it is a game of numbers. We change the numbers, it need not be.
Okay, so thank you.
How do we analyze a circuit? You are supposed to know Kirchhoff's laws. From here, for us, 2 chapters will be running parallel: capacitors and current electricity. But technically, this isn't capacitors only. Right. If there is a circuit which appears very simple and I can solve it without using Kirchhoff's laws, nothing better than that. Directly finish off the problem. Right. What are Kirchhoff's laws? Will be explained. probably in today's class. Suppose I take a simple circuit and try to analyze it like this. This is a switch. I have one capacitor here, one capacitor here. Right? This is 2 volts, this is 4 volts, this is 3 microfarads, and this is 3 microfarads. They're asking you, when the switch is closed, what is the charge that flows through the switch? Find the charge. Find the charge which flows through the switch when it is closed. When it is closed. Find the charge which flows through the switch when it is closed. Right? First of all, initially, what was the charge on both of them? Initially, finally. Initially, switch was open. Can I claim these two capacitors to be in series?
Yes, sir.
What
Yes,
will
sir.
C equivalent be?
1.5.
1.5.
How much?
1.5.
3 by 2, right? Huh? 3 by 2 microfarads. These two cells are in series. What will be V? 6?
Yes, sir.
Yes, sir.
V is 6 volts. So this will be positive, negative, negative, positive. The charge will flow this way, right? This and this will have the same charge. How much charge will they have? C into V.
9.
This will be 9 microfarads and 9 microfarads. Initially, when the switch is open, this is the situation. Anybody with a doubt so far?
Sir, microcoulombs.
Microcoulombs is right. Charge will be microcoulombs. Capacitance was microfarads. So
So you will take
3
the C equivalent will be same for both, we will consider.
C equivalent का मतलब ही both. What do you mean by C equivalent?
Resultant capacitance.
Replacing this with one capacitor.
Right.
Both का सवाल है ही नहीं. Right?
Yes.
Now look at this. When you close the switch, what will be the potential difference across this? These both are connected, these both are connected. Potential difference across this will be 2 volts. Yes or no?
Yes, sir.
3 into 2 is 6 microcoulombs. What will be the potential difference across this?
4. 4.
12 microcoulombs. So when the switch is closed, the new charge on this is 12 microcoulombs. The new charge on this is 6 microcoulombs. So far, so good. Yes or no?
Yes, sir.
Yes, sir.
Now the positive charge from 9 should come down to 6. Matlab this plate should leave 3 microcoulombs of charge. This plate should leave minus 3 microcoulombs of charge. Do you agree with this?
Yes, sir.
Battery is neither a source nor a sink. If 3 microcoulombs is coming, it must come out from the other side. Battery cannot absorb the 3 microcoulombs. Now,
Yes.
look at the lower plate here. 9 microcoulombs with a negative charge rises to 12. That means minus 3 microcoulombs should come to the lower plate. So that minus 9 will become minus 12. Do you agree with that?
Yes, sir.
If minus 3 is coming here, I should have minus 3, or I can interpret minus 3 as plus 3 in the opposite direction. Minus 3 in this direction is as good as plus 3 in the opposite direction. Both means the same. Now plus 3 goes this way, plus 3 comes this way. How much will go this way? Plus 6 microcoulombs will go through the switch. Let me cross verify if I am getting a consistent answer here. Plus 6 minus 3. How much will go here? Plus 3 microcoulombs. Is it not your requirement?
Yes, sir.
1. Now, somebody typed, how did you get the final charge? When I close the switch, potential difference across this will be 2. So 3 into 2 is 6. Potential difference across this will be 4. 12. Now I repeat whole of the addition and subtraction, concentrate on it. 9 microcoulombs should become 12 microcoulombs. So minus 3 microcoulombs should come here, which is as good as plus 3 going in the opposite direction. Plus 3. Similarly, 9 should come down to 6 means plus 3 should be leaving this. Both plus 3s will add up to be plus 6 in this particular branch. If plus 3 left here, by induction minus 3 will leave here because by induction you are holding equal charge. Plus 3 went up, minus 3 will come down. 6 and minus 3 will give me plus 3 microcoulombs. 6 and minus 3 will give me plus 3 microcoulombs. Does that meet your requirement? Yes. From plus 9, it should go to plus 12. So if plus 3 comes, this will become plus 12. And minus 3 comes here, it will become minus 12. It meets my requirement. So how much charge has flown through the switch? 6 microcoulombs of charge has flown through the switch when it is closed. All that we have done is just added and subtracted properly.
So
Huh.
in this, I won't be ignoring the thing that these both circuits are connected. We are considering them as two independent circuits, right?
No way.
So because the 2 volt and 3 microfarad upper setup we are considering as one different, and the lower we are considering as one independent one.
बिल्कुल नहीं. कोई नहीं सकता.
In the final case,
If I take the reference line this to be 0 volts, what will be the potential?
4 volts,
4 volts. What will be the potential here?
6 volts.
6 volts. This and this are at the same potential. This and this are at the same potential.
Right.
So if this is 6 and this is 4, what will be the potential difference across?
2 volts.
And hence I have taken this into consideration. Now this is 0, this is 4. What will be the potential difference across?
4 volts. Alright. So basically the effect of the other got cancelled out.
We don't say that. Language is wrong.
Okay.
Nothing gets cancelled out. Now that's why we say absolute potential is never defined. Somebody will say, why did you take ground potential here? Take 100. I don't mind. Take 100. This will be 104. This will be 106. Potential difference across this will again be 2. Across this will again be 4. So when the switch is closed, 6 microcoulombs of charge passes through the switch. Now multiple choice they can play 2 ways. Either they can tell you plus 6 goes this way or minus 6 in the opposite direction. Both of them will be right. Both simultaneously will not be right. Either of them will be correct. Either you take plus 6 this way or interpret that as minus 6 in the opposite direction.
Done, sir.
Just a second, sir. Excuse me, sir.
Ah.
Sir, have we also taken into consideration the fact that the charge always flows from higher potential to lower potential here?
Will ever charge flow from lower potential to higher?
No, right, yeah, right, sir. So, but sir, in the diagram that you made, I see like it is going from 0 volts to 4 volts plus 3. I was having trouble understanding that bit.
Listen, you are speaking about a situation where switch was open and switch was closed. You are comparing two very different situations. Negative charge going in this particular direction. This is 0, this is 0. What was initially the potential? What was the initial potential when I had 9 microcoulombs?
Yes, sir.
9 microcoulombs, what was the potential? Q by C,
3, sir.
3. Right? Q by C, 3. So what was this at what potential? Negative charge of that minus 3.
Right, sir.
Now what will be the potential difference? 4.
Yes, sir.
Now take that particular value.
I understood, sir.
I will show you this with nodal analysis. You would probably understand better, but not with the same example.
Thank you, sir.
So we consider 2 points of the same wire to be equipotential.
Anytime, charge will flow in such a way so that both will come down to the same potential.
Right.
Can I rub the book?
Yes.
No, listen. Suppose I give you a very simple circuit like this and ask you for the charge on these capacitors. Let me take this to be 30 volts. This is 10 microfarads, 3 microfarads, 2 microfarads. What is the charge on all the 3 capacitors? The circuit is so simple that I will not need Kirchhoff's laws to solve this. Why? Find out C equivalent between these two. They both are in parallel. What is C?
5.
5.
5 microfarads. This is 10 microfarads. This is 30 volts. Now find out C equivalent between
10 by
these
3.
two. How much?
10 by 3. 10 by 3.
10 by 3 microfarads. So what will be the charge on this capacitor? We do the back
100.
calculation. I will have positive charge and negative charge. This will become 100 microcoulombs. So far, so good. Yes, sir.
Yes, sir.
Yes, sir.
Now go back. These both capacitors are in series.
Yes, sir.
So they will have the same charge.
Right.
So this will have 100 microcoulombs and this will have 100 microcoulombs of charge. The same charge flows through the circuit.
Yes, sir.
Yes, sir.
Now go one more step ahead. I'll have positive, negative. I have 100 microcoulombs. I have no issue. This will be positive, negative, positive, negative. This charge is split into both these branches. This 100 microcoulombs which was coming split into both these branches. Do you recollect we have learned how to split the charge into two parallel capacitors?
Yes, sir.
Potential.
Charge on this will be 2 divided by 2 plus 3 into 100. This will be 2 by 5 into 100. This will be 40 microcoulombs. So this will be 60 microcoulombs. If I want the charge on this capacitor, this capacitance divided by sum of both into the incoming charge. Do you recollect this?
Yes, sir.
Sure.
A
Yes,
very
sir.
simple circuit where I didn't have the necessity to use Kirchhoff's laws. I could have solved directly. I could solve it directly. So I didn't introduce Kirchhoff's law. Will there be circuits where I will not be able to solve it this way? Yes. First, let me introduce Kirchhoff's law. Then I will show you those circuits. Take it down.
Done, sir.
Now, it is here. Two chapters are running parallel, current, electricity and capacitors from here for the next 3 to 4 lectures, right? Why? You will understand the law. First law, Kirchhoff's first law is called KCL, not potassium chloride. Kirchhoff's current law, capital K, capital C, capital L. Kirchhoff's current law. It is nothing but conservation of charge. If there is a net current of I coming in, I1 goes into this branch, I2 goes into this branch, this is R1 and this is R2. I is equal to I1 plus I2. Something very simple and elementary which you people must have done even in heat transfer. In heat transfer, this concept is used quite frequently. total incoming current will be equal to total outgoing current. Algebraic sum of all the currents flowing through a junction is zero. Technically, algebraic sum of all currents flowing through a junction. Flowing through a junction is zero. As far as the resistances are concerned, there is only one way of applying Kirchhoff's current law. But if I have capacitors, there are two ways of applying the same thing. I will explain how. First, take it down to here. Are you people there?
Yes, sir.
Yes, sir. Done, sir.
Suppose I have got capacitors this way. I have one capacitor like this, one capacitor like this, and one capacitor like this. Call this C, call this C1, call this C2. Q amount of charge is being pushed this way. So Q amount of charge will deposit on this plate minus Q by induction will push Q amount of charge towards this. Do you agree with that? This Q amount of charge will be split into this branch and this branch. You will call this Q1, you will call this Q2. Q amount of charge splits into both these branches. Kirchhoff's current law is a consequence of conservation of charge. Charge can neither be created nor destroyed. If Q amount of charge is coming, it will split into both these branches. Q1 plus Q2. This is my first equation. By induction, I will have equal negative charges. This will push Q1 charge to the right. This will push Q2 charge to the right. So far, so good. Yes or no?
Yes, sir.
Yes, sir.
The same problem can be looked at in another way, which will be of great help for us in quite a few situations. If I have a capacitor like this and a capacitor like this, I have positive charge here, negative charge here, positive charge here, negative charge here. I took Q charge on C. This is C1, this is Q1, this is C2, this is Q. Listen carefully. This is a negative plate. Besides the negative plate, I have got a dielectric or an insulator, right?
Yes, sir.
Yes, sir.
So charge doesn't flow from this plate to this plate. Same applies to this, same applies to this. Are you trying to tell me that these three plates are mutually connected and isolated? This plate, this plate, this plate are mutually connected and isolated. They are isolated because besides them, you have got an insulator, dielectric. I have a dielectric here, I've got a dielectric here, I've got a dielectric. So these three plates drawn inside the circle are mutually connected and isolated. Do you agree with that?
Yes, sir.
Charge on them, total charge on them should remain conserved. Do you agree with that?
Yes, sir.
I have minus Q charge plus Q1 charge plus Q2 charge. Sum total is 0. Minus Q plus Q1 plus Q2 is the present charge on them. Initial charge on those three plates was 0. Total initial charge and final charge should remain conserved. Q is equal to Q1 plus Q2. In this procedure, there is an advantage. By chance, if I took this plate to have negative charge, I have no issue. The equation will take care of itself. The positive charge comes, which is shared by both the plates. Here I am able to see that the incoming positive charge is shared by both the plates. In some complex circuit, I may not recognize and I may take negative charge and positive charge. Nothing to worry of it. Then you will write minus Q plus Q1 minus Q2 is equal to 0. The equation will take care of itself. Both are two different ways of applying Kirchhoff's current law. They are not optional. You will have to learn both the procedures. Incoming charge is split into both these branches is one way. Total charge on these three plates put together will remain conserved is the second. Initial charge on these three plates should be equal to the final charge on all the three plates.
Sir, isn't the potential difference across C1 and C2 0?
C1, C2 potential difference we don't know. That depends on the remaining part of the circuit.
Shouldn't it be 0 always? Because both of the part will be grounded, right?
बाकी सर्क्यूट एज्यूम क्यों कर रहे हो? ग्राउंडेड क्यों कर रहे हो आप वहां?
Because the negative part of capacitor is always grounded.
तो एक और कैपेसिटर वहां नहीं लगाने का रूल बता रहे हो आप मुझे? You are telling me I cannot keep a component here. I can. That this is one part of the network. That has got nothing to do with this. We will probably in the next lecture we will put multiple components besides that.
No, sir, I'm not asking that.
तो छोड़ दो. ये समझ में आया आपको?
Yes, sir.
बस.
Then, sir.
No, every capacitor need not be grounded. If you ever have a circuit like this and you have grounded this will be zero potential. This will be V. V will be Q by C. right? This will be at higher potential, V naught.
So the other one,
Potential here will be V. It need not be grounded always. Grounding will be given for one part of the circuit, not for every capacitor.
understood, sir.
Wait a second. I used a wet cloth to rub the board. It should write. Now the second law, write down the statement in that. Second law is called KVL, Kirchhoff's voltage law. Second law is called KVL, Kirchhoff's voltage law. The statement is algebraic sum of potential difference across all the components in a circuit, across all the components in a circuit, closed circuit, all the components in a closed circuit, across all the components in a closed circuit is equal to 0. Repeat this statement. Algebraic sum of potential difference across all the components in a closed circuit is equal to 0. All of you wrote the statements.
Yes, sir.
What we mean is, if you have 4 components in a circuit, or say 3 components in a circuit, 1, 2, 3, you will either traverse in the clockwise or anti-clockwise. Sigma of potential difference across all the components will be 0, implies potential difference across the first component plus potential difference across the second component plus potential difference across the third component, sum total should be 0. How do you calculate the potential difference across components with the sign? Listen, this is important. If I have a resistor and this is current I, current flows from higher potential to lower potential.
Yes, sir.
Yes, sir.
So if I traverse in the direction of current, it will be minus IR. If I traverse opposite to the direction of current, it is plus IR. Why are you traversing? You will traverse either in clockwise or anti-clockwise. Yes, the choice is to be taken by us. The decision is to be taken by us. If I go in the direction of current, I am going in the direction of decreasing potential, so minus IR. If I move opposite to the direction of current, it will be opposite to the direction of plus IR. Opposite to the direction of current implies plus IR because you are going in the direction of increasing potential. Potential drop across a resistor is I into R. In the direction of current minus IR, opposite to the direction of current plus IR. Is this point very clear to all?
sir.
Yes, sir.
If I take a capacitor, positive and negative, potential drop across this will be Q by C. I traverse in this direction such that I touch the positive plate first, put it as minus Q by C. Why? If you are touching the positive plate first, you will put minus Q by C. Reason being, when you are going from positive to negative, you are going in the direction of decreasing potential. If I traverse in the opposite direction, I will take it as plus Q by C. I am touching the negative terminal first, plus Q by C. I am going from negative to positive, increasing potential, plus Q by C. In the direction of current, minus, in the direction of current, minus IR, opposite to the direction of current, plus I. You are touching the positive terminal first, minus Q by C. You are touching the negative terminal first, plus Q by C. Right? If it were a battery of EMF, positive plate is at higher potential, negative plate is at lower potential. This is minus E, this will be plus E. When you are touching the positive terminal of the plate, it is minus E. When you are touching the negative terminal of the plate, it is plus E. When you are touching the positive terminal of the plate, it is minus E. If you are touching the negative terminal of the plate, first it is plus E, because when you are going from positive to negative, you are going in the direction of decreasing potential. You are going from negative to positive, you are going in the direction of increasing potential. All three sign conventions should be on the tip of your tongue. We use them extensively. Take it down, please.
Done, sir.
Done, sir.
Let me take a circuit which we already used to confirm Kirchhoff's law. What do you mean by that? You have solved this problem. You had two capacitors here and one capacitor. This was 30 volts. How much was this?
10
10
volts.
microfarads.
V2. 3 and
3 microfarads, 2 microfarads. Am I right?
Yes.
If I were this, I could solve without using Kirchhoff's law. There will be instances where Kirchhoff's law is a must, without which you cannot solve. But here you have two ways. But let me confirm this using Kirchhoff's law so that we gain confidence on Kirchhoff's law. Firstly, I will take positive charge on this, negative charge on this. I'll take this as capital Q. Right? Capital Q charge comes onto this. I will take this to be small q and I'll take this to be capital Q minus small q. Did you people observe? I already applied Kirchhoff's current law.
Yes, sir.
Yes.
Capital Q charge comes here. If small q goes here, I didn't take Q dash here. I took capital Q minus small q. One variable is eliminated. Kirchhoff's current law is used. Now I have to apply KVL, Kirchhoff's voltage law. How many loops do you have here?
2.
You will have two equations. Count the number of variables.
2.
So you are safe. If by chance you had 3 variables, don't try to play smart here telling me I'll take this as one loop, this as one loop, and the outer loop as one loop. You will get only 2 equations. You take for this loop and this loop, they will add up. You will take for this loop and this loop, they will add up to give the outermost loop. You will not get a third equation. If there are 2 loops, you will have 2 equations. If there are 3 loops, you will have 3 equations. So count the number of variables before you start. Here I will apply Kirchhoff's voltage law to this loop and traversing in clockwise direction. And touching the negative plate first, I'll put it as plus 30. Do you agree with this?
Yes, sir.
Yes, sir.
And touching the positive terminal first, minus q by 10. And touching the positive terminal first, minus q by 3. Sum total is 0.
So into 10⁶.
Final answer microfarads. Right?
Yes, sir.
Final answer, because microfarads, it will be in microfarads. So you are touching the negative terminal first plus 30. Positive terminal first minus q by c. Positive terminal first q by c. Now I have two choices. You apply Kirchhoff's law to this loop or the outer loop. Any one of your choice. You can apply to this loop or the outer loop. I will select the outer loop. Reason I can eliminate 30 easily. Right? I selected the outer loop and I will go in clockwise direction only. Negative terminal first plus 30 minus q by 10 minus q by 2 is equal to 0. Two equations and two variables. Are we okay with that?
Yes.
Yes, sir.
Subtract minus plus plus. This will go, this will go. Minus q by 3 plus q minus q by 2 is equal to 0. Right? Minus q by 3 minus q by 2 is minus of capital Q by 2. Am I right?
Yes, sir.
Yes.
Minus plus 6. 2q plus 3q is equal to q by 2. You will get 5q is equal to 3 times capital Q is my equation here. So far so good. Is my simplification correct?
Yes, sir.
Substitute this in either this or this, you get the value of small q and capital Q. Substitute and tell me if you are getting the same answer or not.
Yes, sir.
Yes, sir.
Here, in fact, Kirchhoff's law was lengthier. Here, in fact, Kirchhoff's law was lengthier. Directly solving using series and parallel was easy because of the availability of the circuit's information. First finish this. I will teach you a third procedure called nodal analysis. We will keep using all three procedures for all the problems that will come across from here.
Sir, can you repeat which loops you are allowed to take?
Any closed loop you can take. I took first equation for this loop, right? Second equation I took to the outer loop. You can take second equation for this loop as well. I don't mind.
Okay, sir, understood.
Any closed loop. But if you have got two loops, you will have only two equations.
So can you please repeat that? How to find the number of loops?
दो loops है यार सर्किट में कितने loops हैं?
Okay, number of loops that pass through the battery is the number of loops.
Nothing like that. See, this is one loop, this is one loop.
Okay, sir.
I have two loops here. Suppose you have a circuit like this. I have four loops. I have
Okay,
different
okay.
components.
Understood, sir.
Done, sir.
Can I rub the board?
Yes, sir.
All of you understood how to apply Kirchhoff's law.
Yes, sir.
Yes, sir.
Now, this is called nodal analysis. Nodal analysis. We are learning total of three procedures. First procedure, recognize series and parallel and finish off the problem. Second procedure, Kirchhoff's law. Third is nodal analysis. Don't be under the impression I will learn one and leave the other two. Some problems series parallel will be easy. Some problems Kirchhoff's law will be easy. Some problems nodal analysis will be easy. All three procedures are mandatory.
So, but technically, all three procedures will work for all problems, right?
Need not be.
Okay.
Kirchhoff's law will be universal. It will work for all problems. And that
Okay.
is why in your syllabus, only Kirchhoff's law is mentioned. If you observe the syllabus given by both JEE Mains and Advanced, simple circuits which can be analyzed using Kirchhoff's law. Mandate. If ever it is a subjective paper where every step carries marks, Kirchhoff's laws is the only thing I will use. आई बात समझ में आई?
Yes, sir.
Now, what is nodal analysis? Take this to be 0 volts, this will be 0 volts, this will be 0 volts. मनमानी चल रहा है यार आपका, यहाँ 0 लेने का मन किया ले लिया. हाँ. Absolute potential is not defined. तुम्हें 100 लेना है ले लो, 1000 लेना है ले लो, मेरा लकी नंबर लेना है ले लो, मुझे कुछ फर्क नहीं पड़ेगा. Take some number here. You can start with 0 because there is a reference line. 0. What will be the potential here? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
I don't know the potential here. I will call it V0 and V. How
Yes.
many variables do I have now in my equation?
1.
V0. If I get that, my job is done.
Yes, sir.
Now, what is the charge which flows in this particular branch? Q equal to CV, 10 microfarads into what is V? 30 minus V. How did you assume 30 is greater than V0? No, you have potential positive here. You have taken positive.
Yes, sir.
Yes, sir.
30 will be greater than V0 is your assumption. So 30 minus V0 into this will be the charge which comes till here. Do you all agree?
Yes, sir.
Yes, sir.
That charge should split into these both branches. Do you all agree?
Yes, sir.
Charge which flows into this branch is 3 microfarads into V minus 0. Charge which flows into this is 2 microfarads into V0 minus 0. Q is C. V is the potential difference across. 10 into 30 minus V0 is 3 into V0 plus 2 into V0. 300 is equal to, this is 5 plus 10, 15 V0. V0 is 20 volts. Can I calculate the charge on these both and this and verify to see? This is the third procedure called nodal analysis. First procedure, series parallel. Second procedure, Kirchhoff's law. Third procedure, nodal analysis. Till I complete this chapter, every damn problem we can solve using Kirchhoff's law as well as nodal analysis. Sometimes series parallel will not work because you cannot recognize if they are in series or parallel. We will show you those examples as well. Kirchhoff's law and nodal analysis are not optional. You have to learn both the procedures. Nodal analysis will be easy in many of the situations, but what is prescribed for you is Kirchhoff's law.
But in this also we applied Kirchhoff's law, right? We conserve charge basically.
Sure.
Sir, could you repeat how you said that 30 would be greater than V now?
You took this to be positive, negative. This will be at higher potential. So charge has flown this way.
Understood, sir.
You'll have to make that assumption of positive and negative both for nodal as well as Kirchhoff's law. Kirchhoff's law apply करने के लिए भी you have to assume take a stance.
Done, sir.
Sir, please wait.
Yes, sir.
I am assuming I am giving very good numbers, but I don't know. Playing with 2, 1, 1, 2 should be easy. Here, series, parallel, I don't know which of them are in series, which of them are in parallel. Series, when can I decide? When I'm damn sure it's the same charge flowing. Parallel, if charge splits and adds up, potential difference across them should be equal. Of these both, I cannot claim are in series nor are in parallel. These both, are they in series? No, because charge splits here. So which of them are in series, which of them are in parallel? Not possible. You have two ways of solving it. Kirchhoff's law and
Nodal analysis.
for uniformity in the class, though you will be solving the problem, let us assume charges. Let us assume charges so that all of you follow the same. Shall I take here to be positive?
Yes, sir.
Yes, sir.
What if you might have started with negative? Nothing wrong. Kirchhoff will take care of it. You will get the charge negative. If you have taken the polarity reverse, Kirchhoff will take care of the problem. When you calculate charge, it will turn out to be negative. This is positive, this is negative. This is negative, this is positive. Now, actually, I don't know in this case which is negative or positive, but I'll assume 2 volts dominates, negative and positive. I may be wrong with any of the 3 polarities. I damn don't care. Kirchhoff is there to take care of it. Is that clear?
Yes, sir.
Q1, Q2, Q3. The problem is all yours. I'll keep you people on mute.
So we can assume zero potential anywhere in the circuit, right?
Your choice. Anyway. Sorry.
Answer.
So done.
Answer.
The 2 minutes.
People who have done using both the procedures.
So just nodal analysis.
अरे बिल्कुल नहीं, Kirchhoff's law is the prescribed. Kirchhoff's law किया नहीं तो तुमने किया ही नहीं. Kirchhoff's law mandatory. All of you verify your notes. Kirchhoff's law apply करना ही है. I'm waiting. I will not go ahead unless you people solve using Kirchhoff's law. It's not my choice. JEE का syllabus है.
So in Kirchhoff, we'll have to assume some part grounded.
Nothing. I'll solve using Kirchhoff's law. Please have a look at it.
So just a minute.
Pardon?
Just a minute.
You want me to wait?
Yes, sir, just a minute. Done. Sir, I am getting a silly doubt over here that we are considering two ends of the wire to have the same potential, right?
Which one?
Two ends of the same wire to have a same potential.
Right.
So, but if it is equipotential, how will charge flow through it?
Charge flows to make them equipotential. Initially, this plate didn't have charge. this plate was at higher potential. Charge flows in such a way so that both the plates will come down to the same potential. I have a capacitor, I have a battery. Battery has 10 volts, capacitor initially did not have any charge. What is the potential difference across this? 0. So now
Right.
this is at 10 volts, this is at 0 volts. So charge will flow till this and this come down to the same potential, and this and this come down to the same potential.
Got it.
So during this transition, do you think there will be current in the circuit? Yes.
Yes.
But once steady state is reached, there will be no current through the branch with the capacitor.
Right.
Once steady state is reached, there will be no current in the branch with the capacitor. Firstly, I am applying Kirchhoff's law. Please be crystal clear about it. Practice of Kirchhoff's law is mandatory because that's the only prescribed thing in your syllabus. Both JEE mains and advanced. Clearly, they specify Kirchhoff's law. So don't take chances with it. Nodal analysis. It is my mistake that I taught you people in advance. I should have taught you after you practice all these circuits, right? But then, done is done. Kirchhoff's law practice is mandate. Here, shall I? I'm going clockwise direction in this loop. I will touch the positive terminal first, -1. Negative terminal first, plus Q1 by 2. Positive terminal first, minus Q3 by 1 is 0 is my first equation. You are touching the negative positive terminal first, -1 plus Q1 by 2 minus Q1 by 3 is 0. Is this equation clear to all?
Yes, sir.
Anti-clockwise direction. I am touching the negative terminal first, plus 2. Positive terminal first, minus Q2 by 2. Positive terminal first, minus Q3 by 1 is 0. Positive terminal first, Q2 by minus Q2 by 2. Positive terminal first, minus Q3 by 1 is 0. You have 2 loops, you will get only 2 equations. अगर आपके पास 3 variables है, Q1, Q2, Q3. Think of a third equation. What is the third equation? Kirchhoff's current law. This plate, this plate, this plate are mutually connected and isolated. These 3 plates are mutually connected and isolated. Yes or no? Charge on this is plus Q1. Charge on this is plus Q3. Charge on this is minus Q2. Should be equal to 0. Plus Q1 plus Q3 minus Q2 is equal to 0. 3 equations and 3 variables. Simplification is not very difficult. Right? I expect you people to be in a position to simplify this.
Yes, sir. Done.
Yes, sir. Done.
I will redraw the circuit to apply nodal analysis. Now, I take this to be grounded, or I'll make my life a bit simple to avoid negative signs. I'll get this to be grounded. 0 volts, 1 volt, 3 volts, 3 volts, 0 volt, we know. Are we okay with this?
Yes, sir.
Now, negative, positive, to avoid confusion, I'm taking the same polarity as I have taken in this. You can take anything. No issues with that. But stick to it till the end of the problem. Right? Have a look at it. Plus, minus, plus. Plus, minus plus. What is this quantity of positive charge? Q is equal to CV.
Yes, sir.
Yes, sir.
2 V naught.
V naught minus 0 into 2 is the quantity of this positive charge. Yes or no?
Yes, sir.
Yes.
Quantity of this negative charge. Quantity of this negative charge. This is the direct potential. 3 minus V naught. 3 minus V naught into 2. Why did you put a negative sign? This is negative charge. Quantity of this positive charge is V naught minus 1 into 1. Sum total should be 0. Q1, Q3 minus Q2, you equated it to 0. How many variables do you have here? One variable. If I get V naught, can you tell me the charge on all the three?
Yes, sir.
Somebody asked something which I couldn't hear.
Can you please confirm the answers?
Somebody tell me the answers.
So Q1 2.8, Q2 3.2, and Q3 0.4.
Yes, sir.
Q3, isn't it 2 by 5?
Yes, sir. 0.4.
Q3, 2 by 5. Q1, 14 by 5. Q2, 16 by 5. Microcoulombs. Writing a physical quantity without units is a blunder. Microcoulombs. Can I rub the board?
Yes.
Yes, sir.
Steady state, find the charge on the capacitor. Steady state, find charge on capacitor. Steady state, find the charge on the capacitor. Point we want to drive in here is, in steady state, there will be no current in the branch with the capacitor. Do you agree with that?
Yes, sir.
Are you people there?
Yes, sir.
Yes, sir.
Steady state, there will be no current in the branch with the capacitor. So what is the potential drop across this?
0.
So current passes only in this branch. Current will not go into that branch. Only when the capacitor is being charged, current will flow in that branch. Current will not flow in this branch in steady state. So current is flowing in this branch.
2 ampere.
2 and 3 are in series. Current will be 10 divided by 2 plus 3. 2 amperes of current is flowing in this particular branch. Are we okay with that?
Yes, sir.
Good enough?
Yes, sir.
Now, what will be the potential difference across AB?
0.
3 into 2, I into R. 2 into 3, 6 volts. Potential difference across AB. 2 amperes of current is going. 2 into 3, 6 volts. Yes or no?
Yes, sir.
Whole of this 6 volts will appear across this. Yes or no?
Yes, sir.
Whole of that 6 volts will appear across the capacitor as this is 0.
Yes, sir. So ये कौन सा मेथड था?
This is not about a method. You have to solve using Nodal and Kirchhoff's law. I told you the answer directly simply because I want to explain the concept that potential drop across this is 0. You will solve using Kirchhoff's law and nodal analysis and get the same answer. But the key catch and concept, in steady state, there will be no current in this branch with the capacitor. Potential difference across AB, which applies across this, whole of that potential difference will appear across this, as the potential drop across this is 0. Homework, you will solve this using nodal as well as Kirchhoff's law. Even if you don't get nodal, I am okay. Kirchhoff's law is mandate. Is that clear?
Yes,
That
sir.
is not in my hands, that is prescribed by the JE people. Learning Kirchhoff's law is mandatory. Are you people listening?
Yes, sir.
Yes, sir.
This needs enormous practice. Another 4 lectures will continue with circuital analysis only. Both resistors and capacitors, 2 chapters are running simultaneously.
So we'll get homework from both chapters at the end.
Yeah.
Sir, in series the charge will be same on both.
Series charge will be same on both. Parallel potential difference will be the same on both.
Yes.
See you people in day after tomorrow's class.
Sir, HCV homework.
Day after tomorrow, जो भी next lecture है. We'll take doubts because you have topic wise test on electrostatics. Ardhamainda. Did you
Bye.
understand?
Thank you.
Sure.